This is grade 12 trigonometry revision. Let's go through these questions. It's just 21 marks, very few questions. Okay, the first one, if cos 52 is equal to t, determine in its simplest form the following in terms of t without the use of a calculator. Remember, this t is over 1. We have a t over 1 there, and cos 52 is adjacent over hypotenuse. So when you see a question like this, the first thing you have to do is to draw a right-angled triangle there. Hey, my right-angled triangle is not that beautiful, but this is the angle there, 52 degrees, and it's adjacent of hypotenuse. Your t is your adjacent, your hypotenuse is 1, and then for the opposite, make use of Pythagoras theorem there to get this one is equal to the square root of 1 squared minus t squared, and that is 1 minus t squared. That is our opposite there. And then we use the triangle to determine the values of these ratios. This is equal to what? Cos of negative 52. Which quadrant is this? This is quadrant number 4. Negative 52 is in the fourth quadrant, and sine there in the fourth quadrant is negative. So this is negative sine 52, and then we get our sine 52 from the diagram. Sine 52 is equal to opposite over hypotenuse, and that is equal to the square root of 1 minus t squared. All right, that is the first one there. Let's look at the second question. I'm getting rid of this just to create some space. All right, on our diagram, we have this angle, we have this angle. We need to determine this one also by subtracting these two from 180. Sum of angles, sum of interior angles of a triangle, that is, this is 38. When we say 180 minus 90 minus 52. Now, how do we determine this one? Cos of 19. We do not have a 19 on the diagram, but we should be able to pick that 38 is equal to 19 times 2. So this cos 19, instead of dealing with cos 19, let's deal with cos 38. So cos 38 can be written as cos of 2 times 19 there. Cos 38 is cos 2 times 19. We now have our 19 there. And let's choose the expansion, which is going to have cos 19 there. It's 2 cos 19 squared minus 1. Here is our cos 19. To get our cos 19 now, we need to make cos 19 the subject of the expression there. So we take cos 38 here is equal to 2 cos 19 squared minus 1. I'm ignoring this one. Let me just use this one because that's the one that we have on our diagram. Cos 38 from the diagram is adjacent over hypotenuse, and this is our adjacent there. So this will be square root of 1 minus t squared all over 1. But even if we don't write the 1, it's still fine. So this is equal to 2 cos 19 minus 1. So this is the expression that we have to deal with there. That's the expression we are dealing with, and we need to isolate cos 19. That is, make cos 19 the subject of the expression. We do that by taking this one to the left. So if we take the one to the left, we have 1 plus the square root of 1 minus t squared all over 2. That is going to be equal to, when we take the 1, we are left with this 2, and we have to divide both sides by this 2 also. So we will have over 2, and that is equal to cos 19 squared, but what we want is cos 19 only. So we bring square roots to both sides, and when you bring square roots to both sides, remember to put plus or minus, and it's over 2. This whole thing is over 2. 1 plus the square root of 1 minus t squared. It is all under the square root, and that is equal to cos 19. So we've answered our question here, but we haven't finished. Our cos 19 is in the first quadrant. It's an acute angle, so it cannot be negative. So our final answer then should have positive, should have the positive square root of all these things, right? Just remember, you don't forget to put your plus or minus here, but at the end you need to check the value. Our value is an acute angle, it's in the first quadrant, and that's why we are only taking the positive value here. All right, let's go to the next question. Question number 5.2, simplify without the use of a calculator. Simplify without the use of a calculator there. Let me write it here. This is equal to, we are simplifying this whole thing. So we start with 2 cos of that. This is 2 cos 180 plus x. That is the third quadrant, and cos is negative there. So I have a negative cos x. And then sine 180 minus x. That is the second quadrant, is positive there. So it's times positive sine x. And then the last one is sine 74, no change to that one, all over. This is the same as sine 360 plus x. 360 plus x, that is the first quadrant, and sine is positive in the first quadrant. So this is sine x times sine 37 times sine 53, and then this one can be written as, all right, to simplify this one, if we are not sure, you can factor out a negative, and then you have sine negative there, and we have 90 minus x there, and then close that negative, and then outside we are going to have negative sine 90 minus x, and this is going to be equal to negative cos x. If you do not want to factor out a negative, you can add 360 there to have sine of x minus 90 plus 360 there, and this will be sine of 360 plus this negative 90, you have x plus 270 there, which is the same as sine 270 plus x there. That is the third quadrant, and in the third quadrant sine is negative, right? So it becomes a negative, but because it's a cofunction, it changes to cos x. So you can use this method, or you can use this method, that is up to you. Okay, let's clean this so that we can continue with our question. All right, so we are saying sine of x minus 90, we saw that is negative cos x. All right, now we can get some things to cancel there. I'm going to use a different color, negative cos x and negative cos x, sine x and sine x. I've cancelled there, and then from there we are left with 2 sine 74 all over sine 37 times sine 53. All right, from there what should we do? Looking at this one, 74 is equal to 37 times 2. Let's rewrite this one. So we have 2 sine 2 by 37. We are using the double angle formula there, so we have sine 37 times sine 53. Expand this one on top, we have 2 bracket 2 sine of not 2 squared there, that is 2 sine x cos x, so it's 2 sine 37 cos 37 all over sine 37 sine 53. Now we also have something to cancel there, sine 37 and sine 37, so we are left with, that is equal to 2 times this 2, that is 4 cos 37 over sine 53. What's the relationship between these two? It's cofunctions. So this is 4 cos 37 is equal to sine 53 there. This is over sine 53, and that is equal to, cancel these two, so that whole expression simplifies to 4. So that's what we're supposed to do for this one. Let's go to the last question. You can just pause the video and digest that question. Make sure you fully understand it. Alright, the last question here. Let me remove this, okay, so that you can see the question clearly. Given that 2 sine x over 2 times this bracket, calculate all the values of x for which the expression above is undefined. Remember, for an expression to be undefined, we have to be dividing by 0. So if we are dividing by 0, we are saying this expression here is equal to 0. That's the only condition that we have for this thing to be undefined. So you just equate the denominator to 0. So this is 2 bracket 1 minus cos 2x is equal to 0. But if there was a tan something, if there was tan x somewhere in the expression, we also were going to include the asymptotes. You remember the function of tan, it has asymptotes. So the expression, if there was tan x somewhere, then the expression will also be undefined at those asymptotes. All right. Divide both sides by 2, we have 1 minus cos 2x is equal to 0. And then take this to the other side, 1 is equal to cos 2x, or we can say cos 2x is equal to 1. And then change this one. This one changes to 1 minus 2 sine x squared, and that is equal to 1. Let it go to the other side, we have a 0, and then divide by negative 2. Both sides, we are left with sine x squared is equal to 0, which simplifies to sine x is equal to 0. Now we want the values of x for this boundary equation. We can make use of the function of sine. I hope you remember this function. Sine x is equal to 0 here, is equal to 0 here, is equal to 0 here, and that continues to both sides, to the left and to the right. So we have a 0, we have a 180, we have a 360. So every time we're adding 360, this is 0 plus 3, we're adding 180. This is 0 plus 180 plus 180 plus 180. That happens whether we are going to the left or we are going to the right. So we can conclude that our x is equal to 180 k, where your k is an element of z. Remember, this is positive or negative integers. If you want to go to the left, you just take your k as negative. If you're going to the right, your k is positive. For this one, k is equal to 0. So 180 times 0 is a 0. For this one, k is equal to 1. So 180 times 1 is 180. And then for this one, k is equal to 2. So that's 180 times 2. You can continue. You'll get all the values. So this one should be able to cover all the possible values of x. All right. Let's go to the last question. All right. The last question is an identity. We need to prove that the left-hand side is equal to the right-hand side. So for identities, you choose one side at a time, simplify that one side. If it's necessary sometimes, you have to also simplify the other side until both sides, the left-hand side and the right-hand side, are identical. Then you would have proved the identity. So let's do that for this one. We are choosing the left-hand side. So my left-hand side is equal to, let's simplify here, we have 2 sine x all over 2 multiplied by this bracket here, 1 minus cos 2x, and then this is equal to, I can cancel here 2 and a 2 there, so I'm left with sine x over this bracket. And we can replace, this is a compound, that is a double angle there. So this is sine x, and now over 1 minus, this one has 3 different expansions, so which one should I choose there? What I have in my question should guide me. We have on our right side, there is only sine. On the numerator, there is sine only. So to make life easy for us, let's just take the one that has sine only here. So this is minus, this is 1 minus 2 sine x squared. That is the expansion that I've chosen there. And then distribute this negative into the bracket. We have sine x all over 1 minus 1 plus 2 sine x squared, and bringing it here is going to be sine x all over 1 minus 1. It's a 0 there, so we're left with 2 sine x squared. All right, and this is going to be equal to, remember, this is sine x all squared. We can write it as 1 sine x over 2 sine x and another sine x, just to make sure you are clear with that. Cancel this one, cancel this one. We are left with a 1 on the numerator. On the denominator, there is a 2 sine x. But looking at our right hand side, we have 1 over sine x. We have these 2 here on the left hand side. Is there anything that we can do there? There is nothing else we can do. All right, we can conclude that the left hand side here is not equal to the right hand side there. I'm trying to see if we made a mistake somewhere. There is no mistake. That means the left hand side there is not equal to the right hand side. This is because of this 1 over 2. Alright, that's all I have for you right now. Remember, practice makes perfect. So continue practicing and